Okay, so this time you've really thrown us a curveball with this question.
Yeah.
Did a consciousness have to be around to witness the Big Bang?
Yeah, it's a real head scratcher.
It is. And to make things even more interesting, you want to know if Sheldon Cooper would agree.
Right. Always a good thought experiment.
So, to tackle all of this, we're diving into some pretty fascinating articles from Essentia Foundation and Scientific American, and even a mind-blowing YouTube discussion.
It's some pretty wild stuff. Really gets you thinking about the nature of consciousness and the universe.
It really does. So, to get started, we need to rewind way back to the early days of computing.
Okay, back to the future of tech.
Well, not quite your dad's dusty Commodore 64, but close.
Got it. The pioneers who laid the foundation for everything we take for granted today.
Exactly. We're talking about people like Bill Mensch, who helped develop the Motorola 6800 and the iconic MOS Technology 6502 CPU.
The brains behind the chip.
The very same. And let me tell you, those chips were everywhere. You could find them in everything from arcade games to Apple IIs to toys and even pacemakers.
Wow, they really were the building blocks of the digital age.
They absolutely were. But here's where it gets really interesting. Mensch's deep dive into the world of computing led him to develop something called the theory of embedded intelligence.
TEI, interesting. So how does a computer engineer go from building circuits to proposing that intelligence is fundamental to the universe?
Right. It's pretty wild. But essentially, Mensch argues that by building computers, we're kind of mimicking a process that's happening naturally at a cosmic scale.
Okay, so instead of intelligence emerging from matter, as many scientists believe, he's suggesting it was there all along, embedded in the fabric of reality from the very beginning.
That's exactly it. He sees our technological creations as a kind of artificial intelligence that mirrors the natural intelligence woven into the cosmos.
Wow, that puts a whole new spin on the AI debate.
It really does.
But how does this tie into the idea of consciousness?
Well, that's where things get even more interesting. The article mentions that Mensch's theory, alongside the work of Federico Fagan, seems to point toward idealism.
Idealism, the concept that reality is ultimately mental. That's a pretty radical departure from the traditional view that the physical world exists independently of our minds.
So are they saying that the universe is essentially one giant mind?
Not necessarily a single mind, but that consciousness, in some form, is a fundamental aspect of reality.
So it's like saying that the Big Bang wasn't just this explosion of matter and energy, but also an explosion of consciousness.
Exactly.
Okay, now we're really venturing into whoa territory. And this leads us to the concept of panpsychism, right? The idea that consciousness is a fundamental property of reality.
Right, just like mass or charge. And it's not even a new idea. Even Plato considered it.
So panpsychism argues that even tiny particles have some level of consciousness.
In a way, yes. Think of it like this. We know that matter can exist in different states: solid, liquid, gas. Panpsychists argue that consciousness might also exist on a spectrum.
So from the rudimentary awareness of an electron to the complex consciousness of a human being.
Precisely. And this offers a different perspective on the mind-body problem, which has baffled philosophers for centuries. If consciousness is fundamental, then it's not just a product of the brain.
But rather something that exists alongside the physical world, perhaps even influencing it. Okay, this is getting pretty deep.
Yeah.
But I have to ask, if even rocks and atoms have some level of consciousness, how do those tiny bits of awareness combine to create something like the human experience?
That's the million-dollar question, and it's what critics call the combination problem. It's a real head-scratcher. Panpsychists, they'd say it's like trying to explain the experience of seeing the color blue, but to someone who's only ever seen in black and white.
Okay, I see what you mean.
No matter how much you describe the wavelengths or the physics of light, you can't quite convey that subjective experience of blueness.
Right, you just can't. That's a really good analogy.
Yeah.
And it makes you wonder if there's something more to consciousness than just the physical processes of the brain. Which I guess brings us to quantum mechanics. Because if we're talking about consciousness being present at the Big Bang, we have to talk about quantum mechanics.
We do. And luckily, our YouTube discussion dives headfirst into that world.
It does.
It does. We've got a real meeting of the minds here. We've got Roger Penrose, Federico Fagan, and Bernardo Castro.
Wow, talk about a lineup.
Right. A Nobel laureate in physics, the inventor of the microprocessor, and a prominent philosopher.
A real brain trust.
Yeah.
So for those of us who didn't major in theoretical physics, what exactly are we talking about when we say quantum mechanics? Like, what is it?
Well, in the simplest terms, quantum mechanics deals with the world of the very, very small.
Okay.
So we're talking about atoms and the particles within them.
Subatomic particles.
And the way these particles behave is often very different from what we experience in our everyday lives in the macro world.
So how does this relate to consciousness?
Well, one of the central mysteries in quantum mechanics is something called the collapse of the wave function. So imagine a single particle. Before we observe it, this particle exists in a kind of blurry state of possibility. It's like a coin spinning in the air. It's both heads and tails at the same time.
It's in a superposition, right? That's what they call it.
Exactly. It's in multiple states at once. But the moment we observe the particle, the wave function collapses and the particle chooses one state. It becomes either heads or tails.
So our observation forces the particle to make a decision.
It's a very strange concept, right?
It's so strange.
It really is, and it's led some physicists to wonder if consciousness itself plays a role in this collapse.
Oh, wow.
Could our minds be influencing the fabric of reality at the quantum level?
Now that's a question for the ages, and I imagine that's precisely what our panel of experts is debating.
You bet. Penrose, for example, he argues that our current understanding of quantum mechanics is incomplete.
Okay.
He proposes something called the objective reduction theory, which suggests that consciousness isn't causing the collapse, but rather that the collapse is linked to the emergence of consciousness itself.
Okay, so walk me through that a little bit more, because how could the collapse of a wave function, something happening at such a tiny scale, be connected to consciousness?
Well, he uses a thought experiment to illustrate his point. Imagine a planet with weather patterns, but no conscious beings to observe them.
Okay.
Now, according to some interpretations of quantum mechanics, the weather exists in a superposition of states
Okay.
until a conscious observer, say someone on Earth, looking at a photo of the planet, collapses the wave function.
Okay.
And this would, in theory, determine the weather retroactively.
Hold on. Are you saying that simply by looking at a picture, we could be influencing events that happened billions of years ago on a distant planet?
It's a mind-boggling concept, isn't it?
It really is.
But Penrose himself finds this idea, and I quote, completely ridiculous.
I was about to say.
He believes that the collapse of the wave function is likely a physical process independent of conscious observation, even if we don't fully understand it yet. Now, Fagan brings in a fascinating perspective from his background in computing and neuroscience. He points out that despite their different chemical compositions, general anesthetics all seem to affect microtubules.
Microtubules.
These tiny structures within brain cells.
And these are how, essentially, those anesthetics switch off consciousness, even if temporarily.
Precisely. It's like they're disrupting some fundamental mechanism at the quantum level that gives rise to conscious experience.
Okay.
And if they all target these microtubules, regardless of their chemical makeup, it suggests there's something more profound at play than we currently understand.
So we're talking about a kind of quantum switch for consciousness.
It's a possibility. It's a tantalizing possibility, and it really raises even more questions than it answers. But Penrose, sticking to his guns as a physicist, reminds us that we need to be careful not to conflate quantum reality with the classical reality we perceive.
So just because something's happening at the quantum level, it doesn't mean it directly translates to our conscious experience.
Exactly. There's still so much we don't know about how these different levels of reality interact, but by exploring these ideas, we're starting to chip away at the mystery.
And it's definitely a mystery worth exploring. It's like we're trying to understand how a watch works, but we can only listen to it tick.
Right. We might catch a glimpse of the gears turning every now and then.
But we can't really see what's going on.
Yeah, the full picture, the full mechanism remains a mystery.
Which brings us back to the question that started this whole deep dive. Did a consciousness have to be around to observe the Big Bang?
The ultimate chicken or the egg question.
It really is, isn't it?
Did consciousness come first? Or did it come after?
Right. Did it precede the universe or did it arise from it?
Exactly.
And where does this leave someone like Sheldon Cooper, our theoretical physicist extraordinaire?
Right.
Would he even entertain these ideas?
Given his love for string theory and, his pursuit of a unified theory of everything,
right,
I think he'd at least be intrigued. Even if he approached it with, his usual dose of skepticism.
Right.
I think he'd at least be curious.
He'd probably want to see the math before fully committing to any theory.
Oh, absolutely.
involving consciousness and quantum mechanics.
He'd need some equations.
Yeah.
But I think he'd be open to the conversation at least.
Okay, so maybe not a hard no from Sheldon,
Not quite.
but he's going to need to see some more evidence
Definitely more evidence.
before he's fully on board.
Yeah.
I think that's fair to say.
Okay, so going back to,
Yeah.
the Big Bang,
Yeah.
even if consciousness does play a role,
Yeah.
it doesn't necessarily mean that it existed before the Big Bang, right?
Right.
Because the Big Bang is still, as far as we know, is the beginning of space-time as we understand it.
Right.
So the idea of something existing before that might not even make sense in the context of our current physics.
Right. It's like asking what's south of the South Pole.
Exactly.
It's just not how our current understanding works.
It's a paradox, right? But I think the point is, even if we can't definitively answer this question
Okay.
of whether or not a consciousness observed the Big Bang,
Yeah.
just exploring these ideas pushes us to think differently about the universe and our place in it.
It's like we're standing on the edge of the unknown, but instead of being afraid,
Right.
we're kind of filled with this sense of awe and wonder.
And this thirst for more knowledge.
Yes.
And I think what we can take away from this deep dive is that the nature of consciousness,
Yeah.
it's one of the biggest mysteries in science and philosophy.
It really is.
It might be intertwined with the fabric of reality
Okay.
in ways that we're only just beginning to grasp.
In ways that we haven't even imagined yet.
Exactly. We're just at the very beginning of this journey
It does feel that way.
of trying to understand consciousness.
Yeah.
But it's an exciting journey.
It is an exciting journey.
And who knows what kind of mind-blowing revelations
Right.
await us as we continue to explore
Yeah.
this intersection of consciousness,
Yeah. Of consciousness
physics, and the vastness of the cosmos.
and the vastness of the cosmos. And maybe someday we'll have an answer
Maybe.
that would even satisfy Sheldon Cooper.
Maybe. Yeah.
But until then,
Until then, the journey continues.
the deep dive continues. We'll keep asking the big questions
Keep asking those questions.
and see where it takes us next.
Exactly.
All right. Well, thank you so much for joining me on this incredible journey.
It was my pleasure, as always.
And for all of you listening out there, thanks for diving in with us.